In this lesson, we're going to discuss how to translate exponential and logarithmic functions. If you remember from our discussion of translating algebraic functions, we have this general form. So we have an a value, which would give the direction of my graph. So if it was a parabola and it was a positive a, we would be facing upward. If it was a negative a, it would be facing downward. Depending on the graph, it'll flip that direction. The value of h gives the horizontal shift of the graph. So if I have x minus h inside the function, h is going to shift to the right. If I have x plus h within the function, then I'm going to shift to the left. Lastly, we have a value of k that can be added or subtracted outside of the function. That gives the vertical shift. So a positive k will shift my graph up, and a negative k will shift my graph down. Let's see how that all relates to exponential and logarithmic functions. So here I am in Desmos, and I'm going to show how the graph of e to the x and some logarithm function is affected by translations. So I'm going to start off with a simple e to the x function. Okay, so this is generally what we expect. It's an increasing function. It has a y-intercept at 0, 1. If I make that negative, we notice that now our function flips downward. So instead of having the y-intercept at 0, 1, it's now at 0, negative 1. If instead of e to the x, I have e to the x plus 1, again, we notice how our graph has shifted. Or if I have minus 1, again, I notice how my graph has shifted to the left or the right accordingly. If I add a 1, notice how now my y-intercept is at 2 because my graph shifted up 1. Or if I subtract 1, my y-intercept is now at the origin, which means I shifted down 1. Now I'm just going to look at a general logarithm function. It doesn't matter what type of log because we know they all have the same general shape. So I'm going to look at log base 3 of x. Again, same general shape. The only thing that's different between, say, log base 3 or log base 10 is that I'm going to be increasing at a slower rate. Okay, so again, we see an x-intercept at 1, 0 because we know it's the inverse of the exponential function. If that's now made negative, notice how my logarithm function has flipped. If I add 1, again, we shift to the left 1. If I subtract 1, I shift 1 to the right. And the same thing is true if I add 1, I shifted up 1. If I subtract 1 outside, I shifted down 1.